in this video series. So in the previous lecture we were talking about TensorFlow, and the deep learning is having TensorFlow library. So handwritten digit classification using handwritten. So we will discuss these dataset and these procedure, how to do with that. Before this classification, we will come across this biggest question: should we use Keras or TensorFlow? So as we learned that TensorFlow 2.0 uses Keras as a high-level API. Using a high-level API enables rapid prototype, but we can use high-level APIs when we want to build the model on a low level, and if we want to build something that high-level API doesn't provide. Also, writing code from the scratch strength our knowledge on the algorithm and help us to understand and learn the concept better than directly divided into high-level APIs. Thus, in this course, and we will code most of the algorithm from scratch using TensorFlow without using high-level APIs like Keras. So we will be using TensorFlow 1.13.1. So I'm having this function like load dataset and that handwritten digits classification. I'm going to import this library. So if you are using TensorFlow version 2.0 or higher, then this piece of code will not work. TensorFlow example tutorials. So it will put an error on the screen. So in order to improve that, keeping in mind that it will run only the lower versions like 1.13.1. So in this version you will have that 2.0. So you will have that load dataset which is predefined in the MNIST. So this applies the location where we store MNIST dataset, and one hot is true implies we are one hot encoding the labels 0 to 9 because we are having digits. We are going to recognize the digit 0 to 9. So we in this dataset 55,000 images are training set, and each image of size 784, and we have 10 labels which are actually 0 to 9. Similarly, we have 10 images in the test set. So this is all about the data set. So now we will plot one image, how it's look like, and then image 0, reshape, and then define the number of neurons in which layer. We will have 784, the size of the image that we can see over here, 784. Then we can give the input layers. Then we are having one hidden layers, second hidden layers, two hidden layers. Okay, so the architecture will be like, so I'm here 784 input layers. 784 will give as a features. Then I'll have the 512 hidden layers at hidden layer 1. Similarly, in the next level I have 2, 5, 6 hidden layers, 2, 5, 6 features that will be propagate into the next 1, 2, 8 feature. So I'll give the inputs all these 1 to 8 into the 10 output features, 10 output nodes, and this will represent like 0, 1, 2 up to 9. Alright, so in this way this architecture will be made on the screen, and I'll divide this feature into the different sections on the horizontal line. So I'm going to assign these neurons and then placeholders on this side. So now work through the coding part. So in order to remove that that error which is the compatibility with the TensorFlow version 2 and TensorFlow version 1. I'm going to first install this GitHub link to classify my handwritten digits. Then I'm going to uninstall my current version, that is 2.0 onwards. Then I'm going to install TensorFlow 1.31. I have already done that, so I don't need to run it again. And you can see it's going to first uninstall and then reinstall my older version. So then I'm having the older version, and then I give the input example tutorials dot input data. So it is going to just take that amnest data set from the given library, and you can see that it is going to throw that error. So I'll run all these codes once again so that I can remove that error from my ipynb file. So I'll uninstall my current version of TensorFlow, and then I'll install my older version, that is 1.13.2. So it is asking to proceed. Yes, so I'll say yes, and then I'll hit enter. It will keep installing the older version and keep exploring the path and all these hidden layers and all these necessary libraries. And then it is going to upgrade accordingly. It will remove. So meanwhile we can have the further classification, like how it will look like. Okay, so in the placeholders I'll just define the input layer, that is using placeholder, and we first need to define the placeholder for input and output. Values for placeholders will be feed to the runtime. This is for my input, and this code is for my output. So since we have 4 layers, 4 weights will be there and 4 bias will be there. Similarly, our weights by drawing from the truncated normal distribution with standard deviation 0.1. So then I'll do the same for my weights W1, W2, W3, and then output layer. And this W1, W2, W3 will be as number of inputs and then number of hidden layers. Similarly, number hidden layers and then number of hidden layer 2. Similarly, number of hidden layer 2 and going towards hidden layer number 3. And the output will have the hidden layer number 3 to number output with the same standard deviation 0.1. Okay, so it is still installing. Okay. So then I'll define the bias over there, that is the bias 1, 2, 3, 4, and then I'll have B1, B2, B3 and output. So in the next forward propagation I'll define the model name, then I'll have the layer 1 with the matrix multiplication. Similarly, I'll have the layer 2 with the matrix multiplication of layer 1 with layer 2, and add function. I'm having add function over there with the bias. And then for layer 3 I will do the same thing with layer weight 3 and bias, and for the output layer. Eventually I'll compute the loss. We define our loss function, softmax cross entropy and different parameters. I'll do the same reduce mean and the function, and at the last I will find the optimizer over there. So compute accuracy, y had denote the predicted variables, and then I have the accuracy over there, and then create summary. I'll find the loss function over there and the loss with respect to tensor, and then the train module, what will be the batch size, and what will be the number of iterations in my function to help them make sense of the information. Then I'll start the TensorFlow session, perform training. So eventually it will train the function, train the graph, and train the further iteration till 1000 iteration. Thank you very much. In the next video we will cover up the hands-on practice of this handwritten image recognition. Thank you.